All right, let's get started. All right, what's good, everybody? Welcome back to Algebra with Mr. Peters. Today we have another live stream where we're looking at 5 of the most challenging SAT problems that you guys will see. All right, so let's get started. All right, so when we look at our first problem right here, the problem says that a jar has 10 red marbles and 30 green marbles, and it's asking us how many red marbles need to be added to the jar so that we have 60% of marbles, and those marbles would be red. So the most important thing we need to look at is the fact that we have 10 marbles and we have 30 green marbles. And the overall goal is that we want, out of all the entire marbles, 60% to be red. So what we want to think about is kind of like an equation, right? We know it's going to be equal to 3 over 5, which is the fraction for 60%. And when we look at it, right, we know that we're talking about what? The amount of, or the number of red marbles all over the total number of marbles. And for us to solve this, I always suggest that you draw a diagram. So let's say we had a jar, all right? And then we know in this jar, we have 10 red, 30 green, and we know that we're gonna add a certain amount of marbles that are red. So how do we create this equation? And the way we're gonna do that is setting up a proportion by what we just did. So let's go back, right? So we know we already have 10 marbles, 10 red marbles. We're gonna add a certain amount of red marbles, right? We don't know the amount. And then from those red marbles, we're gonna add it to the total amount of marbles. So this is how we set up the equation. And we're now gonna create basically a proportion and solve. So what we have now is 5 times x plus 10 is equal to 3 times x plus 40. And all this turns into is just a regular equation, right? With variables on both sides. So now we go back, we have 5x plus 50 is equal to 3x plus 120. And now we just simplify by combining like terms. I'm going to subtract 3 on both sides. We have 2x plus 50 is equal to 120. Once I combine 50 and 120, we are going to get, let's see, what is it when I subtract this again? I forgot. Let me look at this. Should be 70, right? Let's make sure. Yeah, so it's going to be 70. Now we divide by 2, and we know x is going to be equal to 35 marbles. Now, when we think about this answer now, guys, there's a trick to it, okay? And the trick is this. So yes, the answer is 35. But what a lot of students will do, right, is they'll think that the problem is asking us to combine and add and talk about the total amount of red marbles. No, all it said was how many red marbles must be added. So we're only focused on the added amount, not the total amount. But for us to check, let's say we wanted to check this problem. Now what we would do, right? Let's say we filled this back in with 35. So once I simplify this fraction, 45 over 75, this is going to give me, now this is double check on the calculator, right? 45 divided by 75. This is going to give me 0.60, which is the same thing as 60%. So when we're talking about creating equations, this is one of the challenging problems or hard problems you're going to see on the SAT. And now we're going to go on to the second hard problem that you'll see on the SAT. All right, so let's erase. All right, so I'm going to free draw this guy, so just bear with me. I'm not a good drawer, but you know what's going on. All right, so we got this. We're talking about circle B. This angle is 45 degrees. Let's shade it in. All right, and write our answer choices. Okay. All right, so this problem, we're dealing with circles, we're dealing with sectors, sectors of or should I say, we're dealing with circles, we're dealing with sectors and finding the area of a sector. And the formula that we use for this, right, to find the area of a sector is theta over 360 multiplied by pi times r squared. Now, when you see theta, guys, it's just talking about the degree measure. And the reason why students get this wrong is just from incorrect substitution or just rushing through the problem. So this is what I mean. So when we're trying to find the area of this sector, we have A is equal to 45 over 360, right? And typically, the reason why students will get this problem wrong is because they misinterpret 12. So they think 12 is probably the radius or the diameter, but no, 12 represents this entire area. So they already did the area for us. We don't have to multiply or do anything to figure out the actual area of the circle. We just have to simplify. So once we get here, this answer already is going to be 12, right? They already told us. We already know what the answer is because we have area. So once we simplify now, right? A is equal to, and you don't have to simplify, guys, but if we divide both the top and bottom by 45, my fraction turns into 1 over 8 multiplied by 12 over 1. We could cross cancel, divide by 4. This turns into 2. This turns into 3. And the area is equal to 3 over 2, which should be B. Now, where students could mess up with this problem is they could think that 12 represents the radius because they're just rushing. And when they come here and they substitute, they'll have A is equal to, and we'll have the same, they'll do this part right, 1 over 8 multiplied by pi r squared, which would be 12 squared times pi. And once we simplify, we would get 18 pi. And this is a way that they could possibly get C, but this is not correct, guys. Just make sure you look at the problem and you understand what they're asking you. Now, let's say we stay on this same topic, right? This was problem number 2. Now we're going to go into the third challenging problem you see on the SAT, but it's very similar to this. So let's just erase some. All right. So now they give us a different circle, right? And I'm gonna actually let's get this whole thing off. All right, so now what they do is they change the circle. Right, so we have this circle and they give us an arc length. They're gonna ask us about arc length and they're gonna ask us about the area of the sector. So let's fill this in first, going a little bit too fast. So this is 144 degrees. Okay, let's write the answers out. Okay. So now they're asking us for the area of this shaded sector. But the difference with this problem now, everyone, is that they didn't give us the area. They just gave us the radius. So this is when we would actually plug it in. So now let's go over the problem, right? So we know what theta is, right? So we go back to the same formula for our previous problem. So we have 144 over 360 multiplied by what? Pi r squared. So we have, let's see, 10 squared pi. All right, so we're good. And basically, once we simplify, guys, we're gonna get area is equal to, and let's make sure, let's hit this on the calculator. So we got 144 divided by 360. We multiply that by 100. So we're going to get an answer of 40 pi. So a lot of times what they like to do with these circle problems is they like to have an answer where pi is not included and when pi is included. All you have to do is just multiply to see if it's the correct answer. But in this problem, we know it's going to be e, right? Because it's just 40 pi. We don't have to do that extra multiplication step. But now what they did in this problem is there's something else they could ask you. So they'll ask you for the area of the shaded sector, and then they may ask you for the arc length. So they're talking about this length right here, this distance basically. And there's two formulas that you could use to solve this, but I'm not going to focus on the one that deals with basically radians. We're going to use theta again. All right. And that formula, let's get a little bit of space. So when we want arc length, it's going to be S is equal to theta over 360, and we're going to multiply that by 2 times pi times r. All right. And once we do this now, this is the important thing that we have to make sure. Because we're always used to pi r squared. This is why I see students make a mistake with this. They may square r instead of just multiplying by 2. So now we have S is equal to 144 over 360. And we're now going to multiply that by 2 times pi times 10. And once we simplify, get my calculator again, right? 144 divided by 360. We're going to multiply that by 2, multiply by 10, and our answer is going to be 8 pi, right? So now if they're asking us this question, right, they're talking about the arc length, our answer would be C. So just make sure that you know the difference between the two because they're definitely going to ask you. Now we're going into what I will call the fourth challenging problem, right, on the SAT. And you're going to see this. It does still deal with circles. So let's make sure. All right, let's go over. Okay. And if you guys have any questions during this live stream, first off, we want to tell you guys, thank you so much for joining us. And two, go in the comment section. If you have any questions, we will try to respond back to you. And thank you guys for joining. All right, so the next hard problem you're going to see on the SAT is going to be a little vocabulary into it, but I'm going to break this down perfect for you guys. So the question is going to say something like this. Oh, well, let me rewrite this. A square All right, so handwriting is real bad, trying to rush, but you guys understand. What the question says is a square of area 2. So we know the area is equal to 2, right? So we know area is equal to 2, right? We're talking about a square, and the formula for a square is what? Area is equal to, I believe, the square root of S. Let's double check that. Oops, no, area is equal to S squared. Sorry, S squared. All right. So area is equal to S squared. So they told us the area is 2, and they say a square is inscribed in a circle. So I'm not gonna lie, if I was taking the SAT, ACT, that inscribed word would throw me off. But just remember, it's just saying, hey, the square is inside the circle, right? And if you draw a diagram, it makes it 100 times easier. So we have a circle. Here goes the square. I know my drawing's horrible, right? And what we're going to do, for us to find the area of the circle, we're going to need what? The diameter, right? The radius. We need some type of information. So anytime you have this type of problem, what you're going to do is cut your square in half because this diagonal right here represents not only the hypotenuse for this triangle, but the diameter for the circle. So now that we know what the area is, right? So let's fill it in. So area is 2, that's equal to S squared. To figure out what the side is, we got to take the square root of it. So S is equal to the square root of 2. So now that we have that done, let's just fill that in. Yep, I'm on the right track. All right. So we have 2 right here, radical 2 right here. Now we can do the Pythagorean theorem to figure this out. Or if you're good with your triangle rules, remember that when we're talking about this, make sure I said this right, 45, 45, 90 triangle, the hypotenuse is just s times radical 2. So basically, if we take radical 2, which is s, and we multiply it by itself, it's just equal to itself, right? Exactly. Now we know what this measurement is. It's going to be 2. Now, why do students get this problem wrong, right? The reason they get this wrong is because this is the diameter. When we plug it into the formula, right, to find area, we have to make sure we take the radius. So the radius is just 1. So we have to make sure that we cut it in half. So now when we go to find the area, right, and let's go back to this. Where are we? All right. We know area is equal to pi times r squared. So when we substitute, it's equal to pi times 1 squared. So area is just going to be equal to pi, right? So when you see the answer choice, this will be a very complicated one or a hard one to pick. So just make sure you understand this relationship because you're going to see the inscribed problem. I'm telling you 100%, all right? Now, another hard problem that you're going to see on the SAT, right? We're going to do a similar example, but I want to break it into 2 problems so you see what the most common mistakes students will make on this problem. All right. So let's erase this. All right, let's write this out one more time. All right, so now with this problem, it's very similar to the last one that we did, right? We're going to have a square inside a circle. The only difference now, they're going to give us a much larger number. And not only are they going to ask us for the circumference, they're also going to ask us for the area. So I want to show you guys both of these problems because this is one of the last problems or one of the hardest problems you will see on the SAT, ACT. All right, we have 10 pi and then just pi radical 50. All right, so let's say we drew out this diagram again, right? We know the area of the square is 50. So I have my square, right? It's inside a circle. No, my drawing's not that good. So, all right, we go ahead, we do the same thing. We split it, right? Man, that drawing looks horrible. But all right, we're ready. So we know that area is equal to 50, right? So we know 50 is equal to, let me make sure we put this out, right? Is equal to s squared. So to find the side, we're going to take the square root, right? So we know radical 50 is equal to s. So that's this right here, that's this right here. So now we're going back to trying to find a hypotenuse, and we talked about that relationship already, s times radical 2. So now in this problem, s is now going to be what? It's radical 50. And once we multiply, right, radical 50 times radical 2, we're going to get radical 100. So what does that mean? The diameter is just the square root of 100, which is 10. So now I know this diagonal is 10. So now let's write down our equations, our formulas, I should say. So I know area is equal to pi times r squared. Circumference is equal to 2 times pi times r. Now, the main reason why students get this problem wrong is because they did not take into account that 10 is the diameter. So if you went in and you plugged it into the area, right? Area is equal to pi times 10 squared. you could easily get areas equal to 100 pi, which is E, but that's not right. Okay, we don't want to do that. We want to make sure that we understand that the radius is 5, and we don't mix any of our equations, right, or formulas, because that does happen. So when we talk about area, area will be equal to pi times 5 squared. So I know my area will be equal to 25 pi. So when we're talking about area for this specific problem, we will be looking at C, right? Now, if we had this same problem and they said to us, Mr. Peters, find the circumference. Number one, yes, we could always find circumference using the diameter, but let's say we use this formula. We have to make sure that we took the radius and not the diameter. So when I come down here and I do a different formula for the circumference, this is going to be equal to 2 times pi times 5. So now circumference is equal to 10 pi. And if I was worried about the circumference, I would get answer B. So just look at how many ways that we could easily get this problem wrong. So these are the 5 hard problems that you will see on the SAT. However, I do have a bonus section. I'm going to go over 1 triangle problems and about 3 or 4 other algebraic problems that you will see. So let's get to it. All right. Let's rate this. Yeah. And when you guys are studying for this test, man, if I'm not mistaken, I do think you guys have the formulas. I cannot remember off the top of my mind, but please just make sure you guys understand how to use the formulas. Practice makes perfect. All right, so in this, we're going to switch from a circle to a triangle in a circle. So let's tell us that if B and C are points on a circle, what is the value of X? All right, so we're trying to find X. Okay, so let's draw out our diagram. So this is what they give us. We have A, B, C. This is 70 degrees, and here goes X. All right, and here goes our answer choices. Let's write this out real quick. All right, so number one, typically I used to be the student that if I see not enough info, I would just think that was the answer because you don't always see it. But in this problem, I'm going to tell you we do have enough information. The reason why this problem is hard is because we don't remember our triangle rules. Please make sure you look over those triangle rules, right? 30, 60, 90 triangles, 45, 45, the equilateral triangles, because they're going to test all those rules, okay? And I'm going to show you 2 of those rules right now and why you need to know them for the SAT. All right, so when we look at this, right, it tells us that points B and C are on circle A. So what we kind of need to know is that, hey, and I think, did I miss anything? No, this is the right problem. Yeah, so what we need to know is that this side and this side are the same, right? And typically with these type of triangles, right, I think they're the isosceles triangle. I had to look at my notes. Sometimes I forget. We know that 2 of the angles are the same, right? And 2 of the sides. So we know if this side is the same, this side is the same. That means that 9 times out of 10, this angle X and this angle, let's call it Y, they're probably the same. So for us to solve, what we need to do is just kind of create a simple equation, right? So 70 plus X plus Y is equal to what? 180. But in this problem, let's just substitute Y with X. Why? Because they're the same exact measure. So now we have 70 plus X is equal to 180. We're going to combine those like terms. 70 plus 2x is equal to 180. Once we subtract, we have 2x is equal to what? 110? Yup. And then when we divide by 2, x is going to be equal to 55 degrees. So this should be a simple one, right? Answer C. Why students may get this wrong is they may take into account that, hey, angle X is 55 degrees. They may add it with each other, right, to get the 110, or they may be lazy and just say, okay, hey, 180 minus 70, or do something similar to that. So just please make sure that you guys understand what it's asking you and just pay attention to those small details. Now, in the next problem, what I want to do, we're dealing with a triangle, but it's a little bit different. And this is what I mean. Right? So let's say they're asking us for the angle measure. Let's go back, right? Erase this too. And we can redraw this. So now we go back. We have a triangle, right? A circle, triangle. Let's see. All right. Oh, that was horrible. Sorry, guys. All right, let's get this more in the middle. All right, let's say this is the middle. Let's get this right here. All right, we have 60 degrees. We have angle A, B, C. All right. All right, so in a problem like this, let's say that they were asking us for one of these measures, like this angle or that angle. So difference with this problem from the last one is this is an equilateral triangle. So rule is what? All the interior angles are the same. So all of these will be 60 and all of the side lengths are typically going to be the same. So in most instances, you're going to have to infer this, or just make sure that you understand this golden rule. Now, let's say they asked us for the area, right? The area. And all we knew or all they gave us was just that one measure, and they gave us that. So, like I said, we're still dealing with an equilateral triangle. And all we have to do is understand that area is equal to, let me make sure I remember my formula. Sorry, guys, I can't remember all this stuff. Is equal to s squared times radical 3 over 4, right? So all you have to do is just plug this in. We can't use the base to height because it's a different type of triangle. So we go through 12 squared times radical 3 all over 4. We're going to get 144 times radical 3 over 4. And once we divide by 4, let's see what is our final answer. I want to say it's 36. Yeah, 36 radical 3. So you have to be able to identify some of these different type of triangles. When it comes to, like I said, the isosceles, two sides are going to be the same, two angles. Right here, the only thing that we knew was just this radius, and we know that this radius and this segment is the same thing, right? Middle of the circle to the edge is going to be the same exact thing, all right? All right. So what other problems do I have for you guys today? All right, so those are the 5 problems that we're going to be talking about on the SAT, those 5 hard problems. What we want to now focus on is some of those extra bonus questions that I was talking about. All right. So in the next problem, they give us a triangle, right? And it's just a triangle by itself. And we only have one measure, and they want us to figure out a missing angle. All right. So when we look at this problem right here, they're telling us that W is equal to 30 degrees. So that's the only information that we have. And honestly, that's the only information we really need. Why? Well, what they want to know is what Z is. But a lot of students, and I made it too, we're normally used to finding the inside measures, the interior angles. But now we're talking about an exterior angle. So, similar to one of the other triangle problems, right? We know two sides are the same. These two angles are going to be the same, right? Two sides the same, two angles the same. Those are the isosceles triangles. So what do I do? Same equation, 30 plus x plus y is equal to 180. right? Let's say I switch the y with x because they're the same. 30 plus 2x is equal to 180. Subtract 30 on both sides. 2x is equal to 150. X is equal to 75, right? So now we know 75 degrees, 75 degrees. Now, the only reason why students are going to probably get this wrong is because they were focused in on the interior angle measure, right? Now that we got those missing angles, to find z, we know that these two angles that are next to each other are going to equal 180. So I'll take 180, subtract 75, and once I do that, the missing angle for z is going to be 105 degrees. So just make sure that when you're solving these problems, you know or you understand what the problem is asking you, because the only mistake is, hey, is thinking that the answer is 75, being used to those interior angles. All right. And man, like I said, guys, thank you so much for joining us on our live stream, man. If you have any questions, always hit the chat, email us. All right. I've dropped the email down below for you guys. Now we're going to talk about some radical equations. And the reason I want to talk about this is because we're going to be distributing. So it gives us this problem right here, right? It says if radical 4 times x plus 1 is equal to radical x plus 25, then what is x, right? Or then x equals what? So this is a real simple problem, but I understand distributing, not having a number under the radical, it can throw you off. I'm with you guys. But let's say we went through and we solved, right? So we multiply, it stays the same, right? 4 times radical x, 4 times 1 plus 4, right side stays the same. Now just remember that radicals are like variables. So this is 4x and this is just x. This x counts as what? 1. So when I subtract this radical to combine with the other, it's like I'm just subtracting 1. So this turns into 3 radical x plus 4 is equal to positive 25. So now anytime we have radicals we're solving, you want to get this radical by itself. So we subtract 4. 3 radical x is equal to 21. Now we divide by 3 because the radical is not by itself completely. You guys know that, right? All right, so we're on the same page. All right, so now I get radical x is equal, I put 7 there, my bad, guys. I'm moving too fast because I love this math. All right, so now we get radical 7 is equal to 7. Radical x is equal to 7. Oh, man, too excited. So what happened right now? A lot of students get to this point and they forget how or what to do because it's not a number. Same thing, guys. You want to get rid of this square root radical, same thing. Whatever its root is, we're going to take it to that power. We don't see a number in the root. We know it's a power of 2. We take that to the second power. We got to take 7 to the second power. So now radical and exponent cancel out. We're left with x. 7 squared is equal to 49. That's your answer. Just like that, right? All right. So now let's just say real quick, right? Now let's say we go back and they gave us a different radical equation, but now this radical equation it has a cube root. What does that change the problem? Absolutely not. And I'm going to show you guys what I mean. Man, my bad, guys. All this talking got me kind of thirsty. All right, let's get back to it. So let's say they gave us a cube root, right? So they said the cube root of x minus 4 is equal to 1. So same thing. You want to get this by itself. Add 4 on both sides. The cube root of x is equal to what? 1 plus 4, which is 5. Bam. So look, same rule of thumb. We're trying to figure out what x is. It's a radical, but instead of there having no number, meaning we would square it to get rid of it, we're now going to take it to its root. The root is 3. So now this cancels out. We're left with x. Take 5 to the third power. So x is equal to 125. Once you plug it back in, think about it. Cube root of 125 is 5. 5 minus 4 is equal to 1. 1 is equal to 1, just like that. So radical expressions make sure you guys understand how to simplify, how to break it down, especially with the cubes, because they're going to throw that in there with you. All right. So now I'm going on to the last problem of this live stream. And man, thank you guys so much for joining us today. We're going to be back again in 2 weeks with another live stream. Make sure you join us. If you've enjoyed this live stream, smash the like button, comment, share. Let us know if you have any questions or if there are any problems you want to see in our next live stream. All right. So the last one, we're dealing with fractions. Okay. And you know they're going to throw some type of algebraic fraction on this exam. So let's write it out. Right? It says, what is the sum of the reciprocals of x squared and y squared? So look, guys, I'm gonna tell you off rip right now. When I was in high school, my vocabulary was not the best. All right. So right now, reciprocals, I know someone else watching this video, they probably forgot. So it's just basically, we're dealing with properties of exponents. So another way they would do this or phrase this to you is this, right? Let me put it like this. Yeah. They're basically saying if you try to add x to the -2 and y to the -2, what will be your answer? Because they're saying the reciprocal of this is just 1 over x squared plus 1 over y squared. So we have to get to this first, and you have to understand the vocabulary. Another way they may show it to you, if it's not by words, is putting it like this, and you have to understand this is property of exponents. With that negative exponent, take the reciprocal. Now that we understand that, how do we solve? I got you. Real simple, right? So we know the common denominator, right, is x squared, y squared. They have to have both terms for us to add it. We know this is missing y squared. So if I come here and multiply this by y squared, right, top and bottom, what happens? All right, we have x squared, y squared. Y squared times 1 is just y squared, right? Let's break this fraction in half so I don't confuse no one. All right, so now we finished the first one. Now the second one, what is y squared missing? We got to multiply it by x squared. What we do on the bottom, we do on top. X squared times 1 is just x squared. Now, just understand right here, typically what they're going to do is they're going to put your variables in order. So you're going to see probably x, y. So even though this says y squared, x squared, our final answer when we add what it should look like as an answer choice should be x squared plus y squared all over x squared times y squared. All right, you will not see y squared x squared. You typically won't see that because, like I said, they put the variables in alpha order. Okay, but guys, this is the end of our live stream. Like I said, 5 challenging problems that you will see on the SAT exam, plus a bonus section. Thank you guys so much for joining us on Algebra 1 with Mr. Peters. We hope you enjoyed this live stream. If you have, smash the like button for us, subscribe to the channel, and leave comments on future videos you guys would like to see on our channel, or if you had questions on today's video. Thank you guys for watching.